Hello everyone, welcome to Mad Flamingo. In this course we are going to learn about embryology. And I know from experience that embryology can be kind of scary. But we will walk through it step by step and break it down to bite-sized lessons. We will start the course at the very beginning, the formation of the gametes, and work our way through to the birth of our baby. Now let's get started. As you've guessed by the title, we are going to talk about oogenesis. Now, Genesis means creation, and oo means egg. So we'll see how the female egg, also known as the oocyte, is created and developed. To see oogenesis happen, we will need to go to the female gonads, the ovaries. Inside the ovaries, which you can see here, the oocytes begin to develop. But when in the female's life do the oocytes begin to develop? Now, this might come as a bit of a surprise because there's this common belief that the oocytes are formed in puberty. But this is not the case. The development of the oocytes begins years and years before puberty, during the embryonic development. And this is exactly what we want to dedicate this lesson to see how the oocytes are formed in the very early stages of embryonic development. So let's bring in the embryo. She's about 4 weeks old now, and she has this funny shape. Around this time, a group of cells, which is called the primordial germ cells, begins to migrate towards the developing ovaries, kind of like that. For now, it doesn't really matter where and how the primordial germ cells are formed. Just remember that they exist and migrate towards the developing ovaries. Once the primordial germ cells reach the developing ovaries, they differentiate into a new type of cell. The cell is called oogonium, or oogonia in plural. So let's take a closer look at the oogonia inside the ovary and see what they do. Now, at this point, the oogonia have a simple role. All they do is expand their numbers like hell through mitotic divisions. These divisions form the many clusters of oogonia that we see here on the screen. Let's take a deeper look at one of these clusters. Now, we can see that the oogonia are surrounded by another type of cell. And these cells are called follicular cells. They have a very important role, and we'll get back to them in a moment. First, let's go back to the oogonia cells. After they form the clusters, the oogonia continue to proliferate inside the clusters through mitosis. Every now and then, some of these oogonia decide that, you know what, I don't really feel like going through mitosis. And instead, they enter meiosis. When an oogonium cell enters meiosis, it becomes a cell known as a primary oocyte, which you can see here in yellow. Meiosis is part of the maturation of the oocyte, and once it is completed, the oocyte is considered to be mature. However, it will not undergo all stages of meiosis anytime soon. Actually, the primary oocyte is arrested at the very beginning of meiosis. Let's see how it is arrested. For that, we will need to go back to the follicular cells that we just met. Remember I mentioned the follicular cells play an important role? Well, arresting the oocyte is that role exactly. What they do is secrete a factor that is very conveniently called the oocyte maturation inhibitor, or OMI. And OMI does exactly that. It inhibits the maturation of the oocyte. We already said that the oocyte is arrested at the beginning of meiosis, but to be more specific, it is arrested at prophase 1 of meiosis 1, and if you want to be super specific, it is arrested at the diplotin stage of prophase 1. And that's all we need to know about the mechanism that inhibits the oocyte maturation. So now we know how the primary oocyte is formed. We begin with the primordial germ cell that becomes an oogonium that enters meiosis to become an arrested primary oocyte. This process goes on until we reach the 5th month of development. And at this point in time, this process stops. So no more primary oocytes will form past that point. If we counted the oogonia and primary oocytes, or germ cells in other words, found inside the ovary, we would see about 7 million germ cells per ovary, or 14 million germ cells in total. And that's a pretty big number, but it's going to decrease rather rapidly from now on. That is because practically all oogonia will degenerate, and so will a large number of primary oocytes. The surviving primary oocytes will get upgraded. Each one of them will get its very own shell of follicular cells. These primary oocytes surrounded by follicular cells, are called primordial follicles. And a baby girl is born with 2 million primordial follicles in each ovary, so 4 million follicles in total. These 4 million oocytes will remain arrested in their maturation until this baby reaches puberty. At puberty, the ovarian cycle will begin and the eggs will resume their maturation. And that will be the focus of our next lesson. Thank you for watching and see you in the next lesson.